All right, can you guys hear me? Everything's good? And that's it, thank you. Yeah, so I'll just wait for Rob to stop talking. Okay, yeah, so I'm Phil Butterworth. I'm a self-proclaimed 5-axis nerd. I am not an expert, I am just a nerd. We can make that clear. I've been machining for about 15 years, mostly in the oil field industry, a little bit of aerospace. I started off in manual machines, like a lot of people, worked my way through CNC up until designing basic downhole tooling for the oil field industry. And now I design and manufacture my own line of high-end motorcycle parts at MJK Performance. So I want to start off by saying I am not a smart man. If you ask me about super NURBS, surface triangulation, even inverse time, I'm just going to look at you with a blank look and just smile happily. But what I am good at is taking seamlessly big tasks and breaking them down into small, manageable forms or small tasks. Or in the machining terms, I am good at making complicated parts fairly quickly. This is all stuff we do at MJK Performance here. So, I'm sure a lot of us have been given drawings like this. Big parts, tons of features. It's like they could have 1,000 features on them, dimensions over top of dimensions on drawings. And on top of that, they needed this part yesterday. And that could be pretty overwhelming. So in this class, we're going to go over how I take complicated parts and drawings like this, break them down into their most basic features, and then how to accomplish each one. We're going to start off with one very simple rule. Don't complain about the part you're given. You might want to run around the shop telling everyone who will listen how much of an idiot this engineer is or how stupid your sales guy is for taking this job with no timeline, and now you have no idea how to get the tools to finish this because it needs to be done this afternoon. But guess what? Nobody cares. No one cares if you're going to complain. They just want to get the part done. So my father has taught me two very important lessons over my years. One, life is a joke, and two, work is just a game. So instead of complaining about this job, turn it into a game. Let's see how fast we can make this. Let's see if we can get this part finished before the customers left the door. And that leads me to establishing my baseline. So now we have our part, we have our deadline, we need to stop sweating, take a deep breath, take a step back, and start planning out our strategy. And that's where my patented 3 S's of machining come in. And the 3 S's of machining are shapes, size, and tolerance. Now, hold on, that's not right. Dr. Phil's 3 key elements of machining are size, shapes, and tolerance. Now you might be asking, Dr. Phil, that is my name, what do size, shapes, and tolerance have to do with machining? Well, I can't really help you with that. That seems pretty obvious to me. But in case, let's start with size. This is serious. So what do I mean by size? Well, when you first get your model and you first get your drawing, we need to establish that baseline. We need to bring ourselves back down to reality, because you might be staring at this drawing or this part and you're looking at 1,000 pieces of information, but nothing's really sinking in. So we need to stop, slow down. And that's what I mean by size. The very first thing I want to do is I want to see how big this part is. If it's a giant car mold, can it fit in your hand? Does it take 2 people to lift it? Is it 40-foot long pipe that needs API threads on the end? In which case you are in the wrong class, because lathe parts are not complicated. I talk about size because if we have multiple machines, we need to know which one to put it in. We're probably not going to put a small bolt in a machine that has a travel of 2 meters or 6.5 Subway sandwiches for the Americans. I also mention size because that directly correlates to how we can hold the part. Again, we're probably not going to tab a part if it weighs 500 pounds. So, how are we going to hold this part? What do we need to think about? How many sides have features? Are there any solid surfaces? How many axes of the machine do we have to work with? Which is a trick question. The answer should always be 5. Lastly, what about operations? Can soft jaws be used? Are there threaded holes you can use to bolt the piece to a fixture? Nothing is worse than finishing the first op of a part and going to flip it over and realizing you have no way to hold it. So that leads me to work holding, when this is a boring slide. And we'll swap it over to that one. So on my computer and on my phone, I have folders and albums filled with different work holding techniques that I've saved through people's Instagrams, YouTube videos, Google searches, things I've seen from companies. I do this so that when I go to program a new part, I have a memory bank filled with examples. And when you're in a rush to make a part, sometimes it's easier to look through some photo albums and see if a part is similar to something else that someone's done than to sit there and think, how can I hold this? So find something similar, and you already know how to hold it. And there are an incredible amount of ways to hold something. You can hold it with a simple vise, a fixture plate. You can do window machining. If you have a 0-point clamping system, like this 5-axis rock lock, you can just mill the studs right into the piece and throw them in the machine. If you can dovetail a part, you should never underestimate the power of a dovetail. This giant piece right here is 20 inches by 8 inches by 4 inches thick, and it's held by an 80 thou tall dovetail, 1 inch wide, 6 inches long. And I can mill that entire thing with no chatter. There are rock solid ways. You can also tab apart if you want to get something done in one operation. So you can mill the whole thing, leave the very end, and just cut the bottom off. And if you're really desperate, you can tape a vise to a lathe. If you're desperate and you haven't seen the inside of a hospital in a long time. So, for an example, let's take this Johnny 5 part that the Hay folks at NY and CNC are making. It's about 4 inches tall with 3 inches wide, and it's some pretty unique shapes. Okay, right off the bat, we know the size. Now let's figure out how to hold it. Okay, I have 2 machines available, a simple 3-axis mill and a 5-axis. Without question, this is going to be a 5-axis part. So how are we going to hold this? So we can finish this in the least amount of time possible, because this is how to make things complicated quickly, not just make them complicated. This part could have been given to us this morning and due this afternoon. Like our customer could have dropped this off at 10 o'clock and they need it for a meeting by noon. And that's happened to me many times. So we don't have time to make special multi-up fixtures or order the proper tooling. We just need to get this done quickly. So how do we hold it? First thought would be maybe something simple like this. Easy access to slots on the side. Do I have a laser? There's cool slots here. We have access to these holes and to these nice sweeping surfaces on the back. But then we're going to run into problems trying to cut. Ooh. Oh, I'm missing that slide. Never mind. Oh, forgive me. So now we're going to have problems trying to reach this bottom piece here. Our machine can't really tilt at that much of an angle to get all of these pieces. So this work holding's out. So naturally, let's flip the other way. Now we have access to all these surfaces here. We can easily drill the holes. There's a hole here we can get through. So that looks pretty good. But now we've lost access to this whole bottom side. Now we could do this in 2 ops. If I go back, we could machine all this and make some fancy soft jaws to try and rough out and finish this side, but that's going to be quite a lot of roughing and finishing on a pretty thin-walled piece on a second op. That's just going to be garbage. So naturally, let's stand it up. Now we have access to the entire piece, top and bottom, all the sweeping surfaces on the side. We have access. This is way better to point. We got access to these holes. We got access to this hole and all these fancy things. But wouldn't you know it, we got this part at 10 o'clock, they need it by noon. I don't have time to order these tiny drills 4 inches long. So we could do this in second op as well, by just making some soft jaws and holding up here, but it's not very soft jaw friendly, this thin wall. So I'm kind of tossing this one out too. So how else can we hold this? How about like this? Okay, now we have access to all the surfaces here. We can hit these holes, all these slots. I can hit all the stuff on the back end pretty easily, just some simple surfacing. But I just can't hit this hole here. So that is the only feature now that I can't hit. But I have this big piece that I finished all the way around here. Now that is very soft jaw friendly. So that means my only second op is holding here and drilling that hole. Seems pretty simple. So remember, there are thousands of ways to hold a part. You don't always have to think in these simple two-dimensional ways. I like to call this three-dimensional thinking. You can hold it in any orientation you want. So now that we've held this part in this really strange orientation, we need support to finish it because it's got some pretty thin walls. So if we give ourselves a little bit of extra stock, like around here, we can actually mold the supports and our own basic fixture straight into our piece. We can add these little sprues here that they do a lot in the dental world. And I think I'm going to strip around here. Better to see. Yeah, so we can add supports up the top and add these little sprues. So we have lots of support from the side. And we could add just a little wall on the bottom so we have an extra base to really hold this piece secure. And so we know we have some holes on the side here. Just a straight hole through and a little countersink. We can actually model in clearance to our little fixture, to our extra stock, so that we can actually hit these with no issues. So as you can see, once we have figured out the size of the part, what machine we can work with, and where to start, we can have the fun with our three-dimensional thinking that is work holding. Oh, wow. So we've got our work holding, we've got our size, we've got our work holding figured out. That brings me on to shapes. So what do we mean by shapes? Shapes is what your high school art teacher was talking about when they showed you how to draw a face. You don't just start with the whole picture and try and do all the fancy shading. You got to break it down into simple shapes and forms that when all put together gives you your final product. So how does that relate to machining? Well, look at your part and see what features we can extract. Are there holes? That's a pretty simple feature. Are they threaded holes? Do they need to be tapped? Do they need to be thread milled? Are there thin walls? Are there flats? Are there hexes? Are there some nice sweeping 3D surfaces? Are there undercuts? Are there radiuses, slots, etc.? Anything that we can easily identify and break down into something really simple. And recognizing these features helps us take a very overwhelming part and make it look very basic and small. So back to this one. At first, when you get this, you're going to notice that, there's lots of sweeping surfaces, all these slots on different orientations. We have these fun little ribs back here and small radiuses, and that can be, you'd probably be freaking out right now if you have 2 hours to make this. But if we break it down, it's nothing more than a couple simple holes, slots. What's easier to machine than holes and slots? Okay, we have this little funny square part here. That might be a bit tricky, but if you got the right small tools, or you have a 45-degree small chamfer cutter, you can figure this out. Now I've kind of lost my spot. Okay, so yeah. So as I said, there's these little holes here. I don't care what size they are right now. I'm just very happy they're here. Okay, yeah. Yeah, so we got these ribs. We have some nice sweeping surfaces back here. They can be kind of complicated, but when you break it down to 3D milling, it's just, I mean, what do you do? Parallel, scallop, contour, steep and shallow. I mean, it's dealer's choice here. You can do anything. The 3D surfacing toolpaths are deadly simple. So now we have this complicated looking part that's nothing more than slots, holes, and surfacing. That's pretty easy. Yeah. So now we've broken this down. This isn't really a hard part at all. This is simple. This is apprentice work, if you ask me. So that brings me over to tolerances. So tolerances sound pretty self-explanatory. I mean, if you're looking at a drawing, it's got plus minus 5 thou here. You think that's all you got to really worry about with tolerances. But to me, tolerance just doesn't tell me what my size limits are. They're also going to tell me what tools I need to use and toolpaths. How should I tackle that? For example, I'm not going to drill a hole that has a 5/10 tolerance with a 1/4 inch drill. So I can just already throw that idea out of the window. But again, I'm also not going to bore a 1/4 inch hole that's got a plus minus 5 thou tolerance when I have a 1/4 inch drill in the machine already. So with tolerances, that's going to tell you how to make it. I'm not going to do these fancy tools like boring when I drill the hole. So tolerance also tells me which features to start with. If I have a thin wall with a hole in it, I'm not going to finish the hole and then finish the wall. That's going to give me a very odd ghosting effect around the hole. It's going to chatter my thin wall because I don't have a lot of support there. So I'm going to finish that wall first and then bore the hole. Seems pretty easy. So that leads me to one of my last points on this slide before we jump to Fusion of basic tool libraries. Now that we know how to hold the part, we know what features it has, we know what our plan of attack tolerance-wise is going to be, we need to think about tools. In my machine, I have a 40-position ACT, and for my 5-axis machine that I have that I do all my prototyping with, and in that, I have a very basic list of tools, and then I got some spots for advanced ones or fancy ones. But in my machine, always, I have 1.5" face mill, because it's a simple size. I have 1/2 inch, 1/4 inch, and 1/8 M mills, and I have them in a rough, a finish, and a long series. I have a 1/4 inch and a 1/8 ball nose. I have a 1/4 inch chamfer mill, and I have drills and taps in all the major UNC sizes from 1032 all the way up to 3/816, because those are the most average holes that I ever see. Using the taps and drill sizes, I always use cut taps in this machine because I can use simple fractional drills. So instead of using a 256 or whatever drill to do a 5/16 hole, I'll use a 1/4 inch drill. That way I have a 1/4 inch drill in the machine. So let us jump over into Fusion quick, if it doesn't crash on me, like it has so many people this week. So let's start back here. Now I could go over some toolpaths and program this part right in front of you, but like I said before, this complicated looking part was nothing more than holes, slots, and a bit of surfacing. But a trick on this that I wanted to show you was instead of patching all of these slots, because we want to surface this big flat area, you can spend 5-10 minutes patching everything, or you can do something that I forget to do 90% of the time, and is that the right one? Yeah. And you can just do offset surfaces or extrude surfaces and just make a quick body. And now that's a weird delay. And now instead of having to work and make patches, we just have this simple sweeping surface. Yes?
I blinked. Can you do that again?
Yeah, let me go back. My wife tells me I'm very good at getting 3/4 of a point across and not finishing it. So if you need me to stop, just tell me. So maybe I can even scroll this back in the timeline for fun. Yeah. Okay. So instead of patching this, like I said, let's just create a surface. Very simple. Let's start with a sketch. I'm going to turn that off. Turn some of these guys on. Ooh. Yeah, so we just start a simple sketch on the back side with the contour of that piece. And in the surfaces work environment, we can just extrude that right back. Let's go back. So we can do, okay, where is this? Jeez, I'm an idiot. Why did you guys even come to this class? Right, I can't remember what I did now. Anyway, God. So yeah, we can extrude that surface back. We can do a split face, make another sketch up here, do a split face on that body to give us that surface now. That surface, because we can do this 3D sketch here, then just split the body, erase the stuff we don't need, and then just do an offset surface for the rest of these pieces on right around here. And now we have a perfectly simple surface that we can do all our 3D toolpaths on, and we didn't have to patch 100 holes. Oh, let's jump over to a couple examples. One thing I've learned, I'm going to jump over here. This is another piece I've done that, again, it needs to get done in hours. This is a little bit interesting apart because we have some bearings holes up here and some nice surfaces. The slot had to have a good surface finish, but this is a pretty tall piece and it's pretty thin. You don't have a lot of support. So one thing I got in the habit of doing is just modeling in more surfaces like this, and then if I jump over to manufacturing, this is stuff I've learned from watching people use Swiss machines, where they would, only turn like a little, like the first feature or something, turn, finish it, and then jump to the next one. We can do that with machining too. So I can just make this surface, do my adaptive, and now it's, I'm not going to finish the whole piece. It's just going to go a couple inches down. It's going to leave me a lot of support, allow me to finish all these parts, then turn that off. And again, I can do another one and finish down a little bit further, maybe from either side, and just kind of slowly work my way down and just finish top features by middle features by bottom features. Tab it off, the piece is done, leaving lots of support the whole way down. So, no, shucks, it's not that good. And speaking of spike balls, that leads me to something that Devin from Autodesk showed me. Some fancy ways to do tool orientation. And this is just the coolest thing, if you ask me. So if you're running a 5-axis machine, even like a 4th-axis machine, a lot of the time you need to get your tool on a pretty fun angle to get in some corners, like around this. Let's say that's walls a couple inches deep. You only have a small 1/4-inch ball nose or something. You can't come down from the side or over, and you don't want to come at a 45 because it's just not that nice. So we can come off just a couple of degrees by simply, we can just model our tool. And if you model your tool, bring it in, add a as-built ball joint down here. Now we can move components. Yeah. Oh, right, come on, move with me. Now we can just move our tool around. So that's pretty simple. And then on the manufacturing side, let's see if I can bring that up. So on the manufacturing side, we can use the axis of this tool model as our tool orientation. So if we say, okay, we can see our tools coming down on this fun angle, but if we go back to design, move that piece, oh, wow. Okay. Thank you. Okay, so make the right selection. Now we can move this guy around. Let's say we go right through the back, hit OK, really scrap our part, generate that, and now our tool is coming from the wrong side. So it's pretty simple. So you can have your tool holder modeled, throw it in. If you have some tight spaces, you know that you're going to clear it. Another way to do this is by a simple, just modeling a simple ball. We have a hole through it. Same thing, use it as built ball joint. Now we can rotate this to wherever we want. If we like a position, we can hit that, construction, throw a plane through it. Sure. Now we have an actual axis here that we can select as our tool orientation. So that's simple tricks, way better than the spike ball if you ask me. And another one that I've started using recently is just actually modeling your XYZ. And the same thing, just move that around. Now you can add a sketch up top to drive 3D surfaces from, and you can just move this around wherever you want. Simple. So, now we have tons of time left. Let's go through kind of some CAM examples. This is, a lot of people I find will have CAM templates and they will have toolpaths they've made and they just dump them into a setup that they can copy and paste from. That never works for me. I'm a very visual person. If I have to scroll through a setup to try and find a toolpath I've made previously that I like, I'm gonna just lose it. I'm not gonna be able to see it. So what I got in the habit of doing is making my own CAM examples. So anytime I come up with a cool like dynamic rotation thing like that, I will make up a little example piece, I'll save it. If I find a toolpath I like, let's see if we can open that steep and shallow one. I will just make a very simple example. I'll make the toolpath and then I have it there. So if I need to do this again, I can just go to my CAM examples folder, find that toolpath I've already made, copy and paste. And it's a lot easier for me to find these than searching through setups. And when I'm trying to do things very fast, I need quick visual things. Let's close. So let's come over here. And let me set the scene for you. This is the part we're going to program. Let's say our customer, Tim, he's come in. It's 10 o'clock. You've just had your first coffee because you wake up late like I do. He's come in. He's given you this model. He's given you a drawing and casually says, oh, I just need this by noon. I got a sales meeting. So like we learned before, this is fairly, like we got a lot of thin walls here. We got some holes. We got some bearing surfaces, let's say. And this needs to be done really quick. So the first thing we learned, we didn't complain about this. That's a lot of wasted time. So we just said, yep, I can do this. I'm going to turn this into a game. I'm going to make sure I can program this part and have it off the machine before you started your car. So we've come up, we've looked at drawing, we've figured out how long this piece is, about 10 inches. We've come around, it's just under 2 inches wide. Let's say it's just over 2 inches tall. Okay, I have 2 by 3 inch aluminum in stock, this aluminum piece. I'll just cut some 11-inch piece so I have lots of room, throw it in my machine. So I've got the stock prepared. I notice that our customer Tim, he's walked by Greg's office, let's say. Greg has a kid in Little League and he loves to talk about it. So I noticed this. I have 20 minutes at least to get this part going. So how am I going to hold this? It's got some thin walls. It's got some pretty fun features. I mean, we could hold it like this so that we could attack the holes up top. We could hold it like this for whatever stupid reason. but I think this is going to be a one and done part. I need to get this done quick. So I'm going to hold it just like this, just as the model was brought in. So simple. Now I can attack top down. I can hit the sides. I can cut this down, and I'm going to tab it off. So let's jump into the manufacturing. Now I've never seen this part before, even though I've already programmed it. So let's just pretend I didn't. They're all protected because I was afraid Fusion would crash. Don't record that part. So what's the first thing I'm going to do? Well, I'm going to look at the shapes, like we said before. What is this part? It's nothing more than, we have a couple of holes here. These are just going to be drilled holes, I'm going to say. Same with the 4 little guys up there. These 3, we're going to say maybe a 1 thou tolerance. Okay, those are for maybe a little press fit or a bearing or something. So how am I going to attack this? I know, like what we said before, I'm not going to drill these holes and then finish this thin wall. I'm going to finish the walls, then make my holes. That's what tolerance is going to tell me. So let's start off. First thing that we can do is finish these 2 walls because we have lots of material in the center. I know I can hit both sides of those walls without shattering anything. So 2 facing operations, done. That piece is programmed. Next thing, let's rough it all out. Adaptive, all the way down to the bottom of the piece. I've programmed that. Now I have 2 facing operations and adaptive. I'm throwing this on the machine right now. And I'm going to let that machine run. These are simple operations. I know the machine's not going to crash because this is very basic. So I'm just throwing those 3 toolpaths onto the machine, letting it run, and I'm running back to my office. I don't have time to sit there and make sure everything's okay. So while that's running, I'm programming the rest. So what am I going to do? Let's finish the floors. Simple. That's a really basic feature, 2D pocket, nothing fancy. Then let's finish the walls. Again, it's a 2D contour. Now, these are thin walls and they're fairly long. Luckily, back into my CAM examples, I've done this before. I've made a thin wall. So I can come over here. I've done this on a piece a long time ago. I know exactly the speeds and feeds I need to make that thin wall. I have it already programmed, copy paste, and now it's in here, and select my geometry, and we're done. So next, we've got our walls finished, we've got our floors finished. The piece is pretty close to being done already. Machine's running. Tim, our customer, he's still talking about Little League, even though he doesn't want to. So we still got a little bit of time. He's trying to wrap it up, though. He's saying, yeah. I mean, this is great. Yeah, baseball. Cool. So I got a little bit more time before he leaves the office, and I want to get this part done before he leaves. So I'm throwing I'm just going to run off those 2, the pocket and 2D contour, post it, throw in the machine, let it run, and I'm back to my office. I'm going to tackle these holes now. Tolerance tells me that that's a 1 thou tolerance there on that hole, so I'm not even going to waste my time drilling anything. This is something I've always done. If I know there's a tight tolerance on a hole, I don't drill. I don't care. I don't even start with the starting hole if it's aluminum. I'll just bore it. 1 operation, it's done. I know that even with the standard step down with bore, I can hit a thou without even trying. It's just going to happen. So don't have to drill. I don't have to do anything fancy. Bore that. Call that done. And then I got the same tool out, so let's just finish the sides. So I got the bore, sides finished, the machine's still running. Let's finish the contours around. And I go through this stuff pretty quick. I don't really worry when I'm trying to make a fast one-off part. I don't worry about having really nice organized, everything's organized by tool size, or, I have my 1/4-inch ball nose does everything it needs to do first before I'm moving on to the next tool. I just finish things that I know need to get done, and if I see them, I'll just do them. I don't have to think too many steps ahead, just 1 or 2. So let's see. So we finished the sides. Now the next thing I see is we need to finish these walls up here, or finish the profiles. So contour, I've done that side. I'm already in that tool orientation, so I know I got a bearing surface there. So I'm just going to bore that. I'm not going to bother drilling. Just tool's already there, bore it, finished. Then same thing, flip over and finish these little guys. Now we got some pretty interesting features down here that are a little bit deep. You're not going to need like a 1/2-inch tool to get in there or anything. So I gotta sorry, losing myself. I have, like I said before, I have 1/4-inch, 1/2-inch, and 1/8 tools in rough finish and long. So without even thinking, I know I have a 1/4-inch long tool in the machine. So I'm just going to finish these sides. Now I can't finish, obviously, this section because it's blocked by that wall. So I just skip that. Same with down here. So I've done that, throw that in the machine. It's running. And yeah, so now I got these 2 holes and a couple holes here. Let's just drill them. Simple. I know I have that. I know I got that drill in the machine. It's 1/4-inch hole, 1/4-inch drill. Done. And then, so that's all, yeah, basic stuff. So let's go quick little tip on some 3D surfaces. Obviously I can't contour this because I'm blocked by that wall. So I'm just going to 3D it. A lot of people will go scallop first because that's a simple, easy toolpath, works really well. I don't like it. I don't visually like it, and I like my customers to get a piece and see really nice lines. So I try and go parallel for 90% of the stuff I do. And the key I learned from Tim at Autodesk for 3D toolpaths is selecting your chain, tool containment. I always, as default, have tool outside boundary, axial offset at minus my tolerance, 4/10, 99% of the time. Select my stuff, hit OK, and it is done. I don't have to worry about tweaking anything. I know that those 2 little pieces are going to be perfect every single time. Finishing this a lot faster than I thought.
Why are you using that additional offset there?
I use it so if I get rid of it or if I make it too big, the tool's going to try and go outside that a little too much, or outside my boundary, and it might fall off a face or go too deep. So if I just bring it in by 4/10 or by my tolerance, I know like it's just going to roll over the edge. And it's just going to be a perfect toolpath. It's not going to go too far over one side, not going to touch this wall here. It's just going to touch these.
Mm-hmm. That parallel, would you stay off the floor like marked by 5/10 or tile to avoid gouging or not shoot?
Yeah, great question. For all my finished toolpaths, like parallel, or if I am going to do a scallop on a radius or something, I will always leave maybe a thou stock to leave or 5/10, because I always find that if I finish a wall and I go to put a radius on and it's 0 stock to leave, it's going to gouge by like a couple of tenths on either side or onto my finished wall. So I always just leave a little bit. I don't do mold work, so I'm not really worried that if my piece is a couple of tenths too big. And a lot of this is just visual. So yeah, I'll always just leave just a tiny stock. Okay, so let's say our customer, he's done. He's done talking about Little League. He's on his way out, but passes the front desk. Margaret's there. She just made homemade muffins. They're amazing. They're a little bit chewy, so I know he's going to have one. He's going to be stuck for another 10 minutes. This is fantastic. I got time. So the parallel's running the machine. I'm back. I only have a couple steps more to do. Let's take a look at these holes here we haven't finished. They are 150 thou. Like I said, I only have tap drill sizes in my machine from 1032 to 3/8, so I don't have a 150 thou drill. But I have a 1/8 ml, so without even thinking, bored, done. It's simple. I might adjust my speeds and features down a little bit because it's like we don't have a lot of room there, so I'll slow it down, but it's going to nail that size. I just know it is. So I don't have to think. I've done this 100 times. I don't think. Just program it, go. So that leaves us with just this radius, the back end, and then cutting this feature here. Everything else is done. Our customer hasn't even left the building yet. So let's cut the side just down a little bit so that we have room to scallop or parallel, whatever you want to do on this edge. Where am I? Yeah, so let's contour that. Let's just give us some space, then throw the scallop on there. I'm not super worried about the contour or really nice things. I just want that done. So program the scallop. That's going to take 3 or 4 minutes to run. I haven't even tested my speeds and feeds. That's just what I had in there before. It's like 100 inches a minute or something. So I don't care about optimizing this. I just want it done. Program it, throw that in the machine. That's running. I'm back in the office. I'm finishing the rest. So that comes down to our last operation of tabbing this part so it is finished, one and done. I'm going to step down this whole back wall. I'm going to do it in 2 sides, I'm going to give myself a rough side. Oh, I didn't know I was half off the screen there. You guys can tell me that. So yeah, I'm going to give myself a little bit of room because I just slot down in one position all the way down. I'm going to have some chips getting caught in there. It's going to leave a bad finish. So I'm going to do a roughing step over. I'm just going to work my way all the way down. Right down to this wall. That leaves me with, say, 1/8 of an inch all the way across the bottom. That's quite a lot of material still. It doesn't seem like it, but that piece is going to be pretty solid. So the last thing I do is tab this. A lot of people ask me what my recipe for tabbing is. 90% of the time, it is small tool. I use a 1/4 inch. I don't want to use a big tool because I don't want a lot of cutting pressure. I want just light tool. And I don't take big cuts. My average is 50 thou. I'll just do 50 thou steps all the way down, and I'll leave myself at least a 50 thou step as my very finished pass. So I still want some material there when I'm cutting it off. If I've left 20 thou and I'm trying to part this thing off, it's just going to be shattering. But if I leave 50 thou, I still have a lot of meat there all the way through my cut till the very end. So that's my little recipe: 1/4 inch tool, small tool, 50 thou step bounds, and I just use the tab feature right in Contour. I don't model any tabs or anything fancy like that. All I do is tab function. Make sure maybe I'm leaving 10, 20 thou. Simple, done. So now this piece is blowing in the wind. Our customer is out the door. He's trying to start his car, but he's got more money than he knows what to do with. So he's got some fancy car with no keys. He's got a key fob that he doesn't know how to work. So he can't open his doors. I finished this piece. A little bit of sanding or something on the edges because I was too lazy to chamfer the whole thing. And now I'm out the door and I've handed him the piece. He hasn't even left the building or hasn't even gone away yet, and he has a finished part. That's how I do. That's how I make complicated parts pretty quickly. I try and turn them into games. I break them down to very simple, manageable tasks and tackle each one. And that's it. And just to prove a point, we have like 20 minutes left. So I got this done fast. So if there's any questions, let me know. And if I went too fast, I apologize. Like I said, my wife always tells me that I'm not good at getting the whole point across, just a little bit of it. Other than that, you guys can take off. I don't know. Thank you.